nothing but a chem thing, baby. Two flipped out teachers going crazy. Lancaster is a district that pays me. Unbreakable, so please don't try to break this. But back to the lecture at hand. Accurate precision.
Oh, hey, Shu.
This is a pretty sweet setup you got going on in here.
Yeah, I'm trying to charge my cell phone. I got my microscope set up. I got all this equipment set up. I'm just missing my lightning cable. Can you grab it for me?
Where?
It's over there. Can you grab it for me?
Where?
Over there.
Where?
Yeah, that's my jam right there.
Are lost there and go through the wire and through the load on fire. They enter the cathode and reduce the cations, and the anions go through the salt bridge back to where? Where? We start at the anode, electrons are lost there and go through.
RedOx Key Concept 1. Oxidation numbers can be assigned to atoms. The oxidation number of an element is always 0. The oxidation number of an ion is whatever the charge listed for the ion is. When we look at compounds, however, we have to make sure that all of the oxidation numbers add up to 0. If we look at our example, Na is +1 when we look up its oxidation number on the periodic table. Oxygen's oxidation number on the periodic table is -2. We then follow through and multiply these oxidation numbers by the subscript. So 2 times +1 is +2, and 4 times -2 is -8. We get a total charge of -6. Now to get the oxidation numbers to add up to 0, that must mean that sulfur has an oxidation number of +6.
RedOx Key Concept 2. Oxidation is the loss of electrons, increase in oxidation number, and reduction is the gain of electrons, lowering the oxidation number, or oil rig. Now, oil rig is a great way to remember this concept. Oil, oxidation is losing electrons. Rig, reduction is gaining electrons. Now, this can be confusing for the first-time chemistry student. Electrons have a negative charge. So when we say that they gain electrons, that means the oxidation number goes down because of the negative charge of the electron. That is called reduction. When we lose electrons, we lose that negative charge. That means the oxidation number goes up. That's why we call it oxidation.
RedOx Key Concept 3. In a redox reaction, the oxidation number of one or more elements will change. If you're trying to determine if a chemical equation represents redox or not, one good tip is to see if you see elements on one side of the equation and then that same element in a compound on the other. That will indicate that there will be a change in oxidation number. Look for synthesis reactions, decomposition reactions, and single replacement reactions. Double replacement reactions, on the other hand, are never redox because the oxidation numbers stay the same on both sides.
RedOx Key Concept 4. Oxidation and reduction can be represented by half reactions which show the exchange of electrons. The number of electrons lost must always equal the number of electrons gained. If you take a look at our redox example here, we have a half reaction for oxidation occurring. We have zinc at a 0 oxidation number becoming zinc at a +2 electrons. Notice we show the electrons on the right side of the equation to show a loss of electrons. In the reduction half reaction example, we've got hydrogen at a +1. It's going to gain 2 electrons to become H2 at 0. Again, notice we show the electrons on the left this time to show a gain of electrons. One final thing, make sure when you do both your half reactions, if you look at your oxidation half reaction and reduction half reaction, that both electrons are equal to each other.
RedOx Key Concept 5. A voltaic cell spontaneously converts chemical energy into electrical energy. Oxidation occurs at the negative anode, anox, and reduction occurs at the positive cathode, red cat. Taking a look at a voltaic cell, we can see that electricity is generated by the chemical reaction. The voltmeter does not create any electricity of its own. Instead, it simply measures the voltage that is produced. The anode is where oxidation occurs. Electrons are lost. We can remember this by anox, anode oxidation. The cathode is where reduction occurs. Electrons are gained. We can remember this by red cat, reduction, cathode.
RedOx Key Concept 6. The features of an electrochemical cell include cathode, anode, and a salt bridge. Electrons flow from the anode to the cathode. Now, for any voltaic cell, electrons will always flow through the wire from the anode, where electrons are being lost, to the cathode, where electrons are being gained.
RedOx Key Concept 7. The salt bridge provides a path for the flow of ions between the two cells of a voltaic cell. When we construct a voltaic cell, we connect the two solutions with a salt bridge. What's the salt bridge? It's an ionic compound that's dissolved in water. When we complete the circuit of our voltaic cell, we have ions flowing through the salt bridge, not electrons.
RedOx Key Concept 8. An electrolytic cell requires electricity to produce a chemical change. It requires a power source in order to drive a non-spontaneous chemical reaction. So if you take a look at our example here, at the very top we see that we have a power source. We have a source of electricity. Now, another way to distinguish between an electrolytic cell and a voltaic cell is, in this example, there's also no salt bridge and it's all contained in one container.
RedOx Key Concept 9. Table J is used to determine the spontaneity of a reaction. It also helps determine the anode and cathode of a voltaic cell. Taking a look at Table J, we see that the most active metals are found at the top and the least active metals are found at the bottom. This can help us determine who wins at the battle of losing electrons. In other words, the metal that is higher up will be the one that loses electrons. For example, zinc is higher up on table J than copper, so zinc is going to be oxidized in the anode, and copper is going to be reduced and is therefore the cathode.
But we never off, always on till the break of dawn. SCIENCE in the hall they call S-Wing. You know we never wear a tie, like my homies, boys to men, it's so hard to say goodbye.
Like this, that, and this, and it's like that, and like this, and like that, and it's like this.
You're going in low power mode.
Plug and chill to the next episode.